Hi, Joe Cerrone. Welcome to CAD 107, Introduction to 3D Printing, in our weekly Zoom classroom meeting. I've released Lab 5, which is Project 12 in the 20 Projects book, which is a base. We have a couple of really good videos in here. And so this video right here goes through the actual build of the part. You can see I've got my partner there, Alan, and we were putting our backgrounds to match our projects at that time. And this project basically lays out how to work the part. Get rid of the sound. Try not to talk like a robot. We're at chapter 3 as far as the textbook goes, and the textbook material from a theoretical standpoint goes through 3D printer workflow and software. And we'll talk a little bit about that, but the video does highlight that quite well, where we're designing with a CAD system, and then we're slicing it and creating an STL file and G-code files, and then we're printing it. Right now, we're running it on 2 different machines. I'm running it on a single extruder Bosch Dremel and a dual extrusion Ultimaker. There's a number of places that you can get CAD models. A lot of times I'll go to Thingiverse and I'll pull models from there. And this is an example of some of the things you can get on Thingiverse. And then I continue to go through in the video and talk a little bit about things like scanning, slicing. And then I have it hooked up to a network. And if you network the Bosch Dremels or the Ultimakers, they have cameras inside, and they actually have apps on your telephone that you can monitor the build. And so you can see there's a prepare button, which is where I can go through and set up the slicing settings. And then there's a build button, which links to the camera in the machine. And so as we go through, I'll talk a little bit about spiralizing outer contour. What's nice is that it's quick and you get a very large build volume because it just goes around the perimeter and then it goes up 1 layer at a time in the Z-axis. So these work really well for things like a vase. You can also modify your vase designs within the slicer by changing the scaling in the X and Y and Z settings. So you can kind of morph it into some really interesting designs. So that's our first video. I go through the entire build and then I show you what it looks like when it completes, and I end that. And then if we come back to our main splash page, here's the lecture on chapter 3, where we're going through and looking at the theory behind our models. And it really is very CAD driven. And so as we start to look at these different materials and where you can get different files from, Thingiverse is probably the first place that I'll go and I'll look for things. Scanning, we haven't really gotten into at this point. It's just difficult. It doesn't come out like as precise as it does with the CAD system. But this is a technology that we'll look into, and it's great for stuff like humans, right? Where you've got, you know, soft round edges and curves and things like that, or hair. Some of the students have taken their old Xbox Kinects systems and turned them into scanners, and they scan themselves into the machine. I don't know if I want to scan myself and 3D print it. And then we slice the parts in the slicer. So that's the lecture. And then here's a video on printing the vase. And in this video, I think I might have shown this one. No, I kind of fumbled around it in the middle here because I could not get it to stick to the build plate. And after you watch the video, if you do watch the entire video, it's only 13 minutes. What you'll find is that I had the build volume too big to fit into the machine. And since it was too big, it wouldn't adhere to the build plate. So we go through the build here. I scaled it down so that I can run it. And this was pandemic stuff, so we were running it. There's also a print cloud. And so if you go to YouTube and you go to Dremel print cloud, you can print remotely to these printers. And what it will do is it will ask you for a token. And so you can use these online slicers, and then you can send a token to a specific machine, but you still need a human to put the pallet in and to push the button to say go, which I think will probably change. I imagine you could do that remotely, but it allows you to manage a pod of 3D printers. And then let's say that all 15 people each got one printer. I could tell you, submit that print job by midnight tonight to your printer. And then I could have somebody who goes and runs all the printers at midnight and just pushes the button and retrieves the tokens. And then the parts theoretically would be done by the morning. As we look at the project for Lab 5, you're going to want to use a B-size metric title block. The actual PDF of the lab, you should get that from the content section, because this one doesn't have any dimensions on it. And so that's what it looks like right there. But if we go to the content section, and then we go, I've released module lab number 6, which is the memo block. So you guys who are working ahead can have something to look forward to. Here's our lab 5. And you can download the project file and just use mine. You can take a look at the way the document is. And I don't think this, I think this is the same document that's in error. So if you go to the textbook, and we download this and open it. This is a cool project. I might bring this one back. It's a lampshade, and we can use some semi-transparent materials for that. We had some really good projects in the past with that. Here's our chip clip. I like the tape dispenser. I think whoever wrote this book liked office supplies. Here's our stationery holder. We'll do a small box. Our do not disturb sign. And finally, our vase. So here's the rules on the vase. What I'd like you to do is I'd like you to model it according to the dimensions on here, but you can change it. 300 millimeters is pretty big. I'm not sure. Let's see what the Dremel build size. So 10 inches by 6 inches by 7 inches. And so it'll be 10 length by 6 width, and I believe 6.7 tall. So if we go and convert, and you guys from Europe are 300 millimeters, we can see that it's about twice as big. So I'll be scaling these to half size to get them to fit. I also put another video in the lab 6, excuse me, lab 5 that I found was interesting. And so what I thought I would start doing would be to put in video links. A lot of times I'll watch the videos and then I'll make my own. But there's a very good video here on using Cura. And Cura is the software for the Ultimaker. But they all look very much the same. And so here's a video demonstrating how to use Spiralize Outer Contour, and it's under special modes, and you just check it off. You can adjust the wall thickness. And so this is how the Spiralize Outer Contour will build. To get a wider contour or to get a thicker outside shell, you can adjust the wall line width. And that's about it where they go to. They also talk about using different nozzles to extrude more material so you have a thicker build as well. When you see this right here, what they're using is a program called Octoprint. And what it does, at least what I think it is on this machine here, on this video, is that after every layer, it parks the head in the corner, the print head, the print nozzle, and then it takes a picture. So it's a very slow process because it slows the machine down by about 20 seconds per layer. But the videos look incredible because you get this, complete build volume, which might have taken 7 or 8 hours in about half a minute. So that's one video. And then the other video that I have in here, I kind of was looking for some other vase designs. And so under YouTube, I really like this vase that was done in SolidWorks. And I was thinking about showing how to model that today. It's really quite simple. What he did was he created 5 planes. And I think he put them all 50 millimeters apart. And then after he created the different planes, he sketched on each of the levels a geometry. And so he goes through and does it on the first plane. And then on the second plane, he makes a larger diameter. Third plane, he makes a smaller diameter. So he kind of changes the diameter on all of these different planes. And then he kind of scooches it up to the top. I don't know why he didn't do that in the first place, and then he'll use a loft program and he lofts these and it looked really, really great. I really kind of liked this vase. So you're welcome to modify the design using Spiralize Outer Contour. And if you're a SolidWorks person, what I'd recommend you do is you emboss something on there. They make great Mother's Day presents. All right. Back to project 5. So our latest project will be to create this vase. And as we work with the vase and we work with these Spiralize Outer Contour projects, if we download the drawing file and I open it, here's our vase project. I don't know why my UCS icon is upside down, but I'll just fix it by saying UCS. And then I'll go back to world and then the z-axis is facing in the right direction. And essentially what you want to do is you want to create your shape. And typically what I'm doing is I'm using the metric title block. So this is the metric template. And that way the units that you use will come in cleanly into the slicer. And what you can do is you can create your geometry. And so I'll just say, let's look at the assignment if I have it there. So we're looking at 78 millimeters to 55. So if we come back to our CAD system and I want to draw a circle here, I could go with a 25 millimeter radius on the bottom. And then what I would do is I would copy it in the z-axis. And so a lot of times what I'll do is I'll create all the geometry on the floor. It just makes it easier. And so if I come in here and I create 3 or 4 circles, then what I'll do is I'll use a 3D workspace and I'll use 3D move. And what I'll do is I'll move these up by grabbing the z-axis, and I'll move that up. Let's say if we're going to go half of that size, we'll go 150 at the top, so we'll say 75 in the z-axis. Hit escape, 3D move. We can move this one here too. Grab the rocket and we'll move that up 150. And then what we can do is we can use the loft function. And so lofting is right here. And so we can loft this between these different shapes. I probably need one more circle there, so I'm going to hit escape. And let's make one more. So we'll say circle, hover, acquire it, and let's go with about there. Arg. Problem is my O-snap was grabbing. And we'll 3D move that. And we'll go with 160. And then we'll loft that again. There we go. We'll hit enter twice, once, twice. And you don't need to shell the part. What you want to do is you want to extrude it. I'm sorry, export it. And so I'll export this to my CAD 107 directory. And I'll just leave that name there as an STL. We'll save it. We'll select it. We'll hit enter. And then what I like to do is I like to go into 3D Builder and open that file. Now, sometimes it will glitch. It will give me a problem. So I'm going to say open, and then I'm going to load an object. Here's my project. It's an STL file. Comes in here. And then what I'll do is I'll check mark that I want that model. I'll click on it. I'll say edit. I'll say emboss. And then I'll put on, you know, a message where I can just say, let's just say open. Save. Now, if you guys want to do a little bit of research on how to take images and convert them over, that would be great. I've had some students who know how to do that, where you can go out there and get a logo like the Cubs or the Bears, and you can emboss these logos on there. I just haven't figured out how to do it yet. And so here's the embossing. Now I know whose this one is. And then once you have embossed it in 3D Builder, save it. And it'll save it as a 3MF file, which I think is fine. So I'm going to put this in my 2021-107 directory. And then I'm going to come into my slicing software. Now, we can do this on a couple of different machines. Let's stay with the Dremel. I would like to start doing some of the Cura for the Ultimakers because we'll be able to do dual color. And we'll also be able to print with dissolvable support material, which is really cool because we could put something inside of the vase. Maybe we print a clear vase and inside we put, you know, a flower or something inside. People will be like, well, how'd you get it in there? And it'd be like, oh, I grew it. All right, so we'll open this file. And then here's this 3D object. Looks like it's the one I just created. So we'll say open. And see, that's the glitch that I get. Sometimes it'll give me this error where it thinks that the part is bigger than it really is. So I'm not going to be able to work with it, I don't think, because I'm not sure how to clean up that little trail. I'd probably have to move it to the origin in 3D Builder. And so if I go here to move it, and then I zoom this down, let's see if I can just grab it and move it. And if I say X0, accept, and Y0, and then I export it again. So let's say save as. We'll just throw an X on there. And then we go into our program. We'll delete this one. And we'll open up the other one. Same thing. Unfortunately, I don't think this will go. Let's see what happens though. So we'll click on it. We'll move it. Get used to the buttons on all the other software. No, I don't think I'll be able to build it because I don't think it'll completely hit on the build plate. And so if I try to, it's really giving me a hard time. But look, it just fits perfectly. At least I did my math right. And you're welcome to emboss it with SolidWorks or with AutoCAD. One of the things that we'll be doing is looking at, yeah, it won't, is looking at how the softwares will be able to manage that. I'm just going to go with a new one. And I was hoping that it would put it in the middle, but it didn't. All right. Live TV. So let's get the other one. Open it. I think it's this one. Yeah. And then I can click on it. You can move it onto the build plate. And then it looks like it fits. If I hit prepare. It almost fits. See how it has this little perimeter around the outside edge? It has to be completely within the build plate. Let's see if it'll prepare it now. So I'll scale it down slightly. I guess my math wasn't as good as I hoped. Go to 90%. Now it fits. Now I haven't used Spiralize outer contour, so it's going to be a huge build. $12 and 45 minutes. So this would be ready at 10 o'clock at night, maybe 11. If I wanted to morph it, what I can do is I can uncheck uniform scaling, and I can say, well, let's make it a little skinnier here. Let's go with 60% here. And let's go with 20. Well, that wasn't good. We'll go back to 90. And then let's go with it doesn't really seem to do much in the Y axis. So I'm going to go back to 90 there. And then let's see what happens here with the Z. Yeah. So again, you can come up with some really different design type things if you care to do it. One of the students did a lampshade, and he made like an ice cream cone. It looked kind of like a Dairy Queen soft serve ice cream, and it was really a cool looking lamp. This is ice cream cone lamp. Now, when we go through and we look at how to prepare this, what we want to do is to go down to the special modes, and we want to check off spiralize outer contour. Now, we were at 12 hours, 45 minutes. I also want you to look at how many grams of material it uses, because this is how you calculate out your costs. Typically, the Dremel comes in 75 kilogram packaging, and then we can look at, well, how much material will I need to make this print? Will I have enough, 750 grams of material. So as we look at it, I'm going to start having people calculate out the cost for the materials. And then you can also calculate the cost out based on cubic inches or cubic millimeters as well, where when we were first getting into 3D printing with the Stratus dimensions, we would charge about $12 a cubic millimeter, I believe. And so typically we were printing stuff for about 50 bucks. Prepare it. All right, I didn't see anything go from spiralized outer contour. Let's see, did I do that? No, there we go. Try it again. What a difference. An hour and 39 minutes, and I have this beautiful looking vase. Now PLA, and depending on the quality level of the material, probably won't hold water. It might. You could look at, beefing them up. But certainly an hour and 39 minutes is certainly a workable project. And so I don't think I'll print it, but it looks quite decent.
Hey, Joe.
Yo.
What does spiralizing do?
It basically takes the print and just goes around the perimeter of the part. So it'll complete the build in the Z axis.
Oh, and what previously was it putting some structure inside? Is that?
Definitely. What it was doing is
Gotcha.
So this is hollow.
Yes.
And then if I were to get rid of the spiralization,
okay.
You would have that fill pattern.
Okay. Sorry, I guess I missed that.
No, that's quite all right. It makes me feel like somebody's listening.
You certainly try to.
All right. So that's the project. That's the basic rundown on it. Please add your own branding to the parts. See if you can figure out how to do it in 3D Builder, or make the part in 3D Builder, and then be able to bring that in. But like I said, if you have that glitch like I did, we do what we can with it. All right. So with that, I'm just going to go back to the main splash page. We'll wrap up our Zoom meeting, and then we'll work with some of the 3D printers. Okay, so there's project 12, creating a vase using spiralized outer contour. You can also do some other things if you guys want to bring in your own materials. It depends on what machine. I should qualify that, but you can, there's some really cool materials out there, but I've got to check the warranty information on the Bosch Dremels because I don't know if they will maintain the warranty if I use like a rainbow type of a filament. Back to the main splash page. But I do have some transparent materials, which if you're interested in working with that, that would be cool. So here's the videos, lab 5. Project 5 will be due October 8th. And I've also released project 6, which is going to be a memo pad. And we're just going to continue working on the projects from the 3D projects book. All right, with that, I'm going to end the video and I'll open things up for questions.